Bienvenidos, Ushamdid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum, and in this packet tracer tutorial and solution set video, we're going to be taking a look at packet tracer 26.2.3. Now, this is probably one of the more difficult packet tracer activities that you'll attempt. And interestingly enough, this is actually a packet tracer activity that comes from what used to be the CCNA security course. So this was an activity that you could have found or you could have run into had you taken the CCNA security course back when it was around. But this is a fantastic activity, and so let's dive in. We're going to look at how to mitigate attacks by configuring IP ACLs. And so here is the activity, and this is our topology we're going to be working with. We're going to verify some connectivity. I'm going to talk about some of the common mistakes that learners run into, especially with the SSH command syntax that we have down here. You can also see, much to my chagrin, that we have passwords that we're going to have to be putting to get into the console line, into privilege exec, and when we SSH. So let's go ahead and start with our verification from Pca right over here. And let's give ourselves a little bit more room with which to work so we can see some rich output here from the command window. And so we're going to say SSH, and that is a -L. So right out of the gate, this is one of the first mistakes that I see learners make, especially learners new to SSH, is they'll assume or think that that is a 1. And if you put a 1 in here, right, what's going to end up happening, you see how much that looks like, you see how much the 1 kind of looks like the lowercase l? So it's supposed to be a lowercase l, but if I leave the 1 in there and we put the username in here and then 192.168.2.1, and we're SSHing to the loopback interface of router 2, it's going to come back and say command unknown or invalid command, right? Because we've got the 1 in there. And so this is the first common mistake. It needs to be an L, as in Larry. And then you'll notice that it's going to work. And so now let me get the Cisco SSH PA55 password put in here, and there we are. We're on router 2, right? So if I say show run, if I say show run, we can see the running config on router 2, and you come down here, and this might be of some help if you are doing some validation work in project number 3. If you wanted to set it up so that you could test your access list that you create to place on the VTY lines, you could do something like this, right? Create a switch virtual interface for the VLAN in question using the PC that you're going to be attached to the specific VLAN. All right, so that's how we test connectivity. So now from PCC, let's verify connectivity to PCA. So here's PCC over on the right-hand side of the screen, and let's stretch that out just a bit. All right, and so here we are with PCC. And we're going to be checking, what exactly are we checking here? What did I miss? From the command prompt on PCA. Okay, so we did that. Wait a second, did I miss something here? From PCC, verify connectivity to Pca and R2. Oh, I see what they're asking for, I'm sorry. I was looking at this, so open a web browser on PCA. Oh, open a web browser to PCA. Sorry about that. So let's pull this up. Let's get the web browser opened up. And again, connectivity is going to work 192.168.1.3 because we haven't applied any ACLs yet. So we're able to do that. That works great. And again, if we wanted to test the SSH, and let's make sure that we do that, let's go ahead and say SSH -L 192, SSH admin 192.168.2.1 and Cisco SSH PA55. All right, so there we are on router, router number 2. So we've got connectivity throughout the network right now But now is when we're going to be locking things down. And always a good idea to validate that things work first before you start applying the ACLs, right? You want to make sure that things are working as they're supposed to before we start applying the ACLs. And so I know we're going to be working on router 1 and router 3 here. So let's go ahead and get those windows opened up. Now, the first ACL, ACL 10, by definition, because it's less than 100, strictly less than 100, so it's 99 all the way down to 1, are our standard range of ACLs. And so they're asking us here to create an ACL. We're going to do it on router 1, 2, and 3. And if I remember correctly, I think we end up, when we finish this, we're at 75%. So this part of the activity is going to give you quite a bit of percentage points. So we're going to use the access class command to then apply it to the incoming VTY lines, and we're going to actually put the exact same ACL, and you can see here step 1, 2, and 3. We're going to apply the same ACL to router 1, router 2, and router 3. And what we're saying is that configure ACL. Oh yeah, so we're only allowing PCC to be able to SSH to any of the routers. Now pay close attention here, because the way they phrase this, so they tell you configure ACL to block all remote access. So they get you kind of thinking, oh, well, I'm going to deny. And then they say, except from PCC. Another way that you could have phrased this that might in the ACL context make more sense would be to say, permit PCC to connect to all 3 routers and then deny everybody else. But again, that would make it too easy. If you were to read it, you'd be like, oh, I know exactly what I'm going to do there. I'm going to go ahead and do a single permit line because I've got that implicit deny any at the end. And so let's go ahead and dive in. Oops, sorry. Let's go ahead and dive in here, and it's Cisco Pca55. And this is the worst part of the activity here, is having to put all these passwords in. Cisco ENPA55, and there we go. And we will need router 2 just for a brief ACL here to get this first ACL on there. And so we'll swing back over to router 2. So here it's going to be Cisco Pca55 and then Cisco ENPA55. All right, so here we are on router 1. So what is this ACL going to look like? Well, we're simply going to say access list 10. We know the number is going to be 10. And so now we're dealing with this statement, block all remote access except PCC. So we'll say access list 10, and we're going to permit 192.168.3.3. And again, if I pull PCC up without going to the addressing table, we can simply see that it's 192.168.3.3. So back over here to router 1. Now, this, I could do quad zeros, right? And maybe we get the credit and the activity for that. However, my guess is, if I remember correctly, is they're looking for this. And you'll notice right away in the lower right-hand corner there when you see the completion percentage. So access list 10, permit host 192.168.3.3, and we get 4% for that. And so my question to you is, do I need to put a deny any at the end of this ACL? And the answer is no, because it's implied that there's a deny any at the end. In other words, what I'm saying is, do I need to come in here and say access list 10, deny any? And no, I don't, because remember, at the end of every ACL, whether it's standard or extended, whether it's named or numbered, at the end of every ACL is an implicit deny any, right? And in a standard, you say deny any, and then deny IP any in an extended ACL. But you get the point, right? There's an implicit deny any at the end of every ACL. All right, so now we need to apply this to the VTY line. So, line VTY 0 to 4, and we're going to say access class, and we put our ACL number 10, and it's in the inbound direction. So connections that are coming into router 1, trying to get to the VTY lines, only PCC is going to be allowed, right? And so this is something that we could test right now. So I could come to PCA and we could go ahead and say, whoops, let's get off of router 2 there. I could come to PCA and say, not ping, SSH -L, SSH admin, and we could try to go to router 1's IP, which I believe is 192.168.1.1, and there we go, connection refused by remote host. So now that same ACL, those same steps right there are going to be required. So Cisco Con PA55, Cisco ENPA55. So those same exact steps are going to be required in order to configure router 2 and router 3. And again, very straightforward, access list 10, permit, host, and 192.168.3.3. We say line VTY 0 to 4, and then we say access class 10 in. And you'll notice we're at 50%, right? We've configured router 1 and 2 with just the first ACL. The activity's already got us at 50%. So you can see that that portion of the activity, this first part is going to be 3/4 of the activity in terms of scoring. So access list, what am I doing here? 10, permit, host, 192.168.3.3. And then we're going to say line VTY, 0 to 4, access class, 10 in, and we're at 75%. Now, the good news is we're at 75%. The bad news is that that is probably the easiest part of this activity. This activity is going to get exponentially more difficult here as we move on through the activity. So now let's go ahead, now that all routers have that ACL applied, so that only PCC can SSH to those routers, let's come back to PCA. Let's not go to router 1. Let's go back to router 2, which we saw that we could successfully get to. And now we get connection refused by remote host. Because the ACL, and remember, ACLs are not stateful, right? They are just simply looking at every packet and checking that source and or destination IP address field in the port information, depending on what kind of ACL it is. With a standard ACL, we can only filter based on source. So when these SSH packets show up here to router 2, and it's going to hit the VTY lines trying to get logged in remotely, it's going to look at the source field and say, all right, does it match 192.168.3.3? If it doesn't, then I'm going to deny it. And that's exactly what just happened right here, right? And so from PCC's perspective, we should be able to do the SSH command, and there it is right there. So Cisco SSH PA55, and it works, right? Oops, sorry, and it works. So we are now on router 2. So from PCC, I should also be able to get to SSH-L, SSH admin to the 209.165.200.225, and you can see that that works. Cisco SSH PA55, and I'm back on router 2. And we already tested PCA, and it did fail, right? So again, that's the easy part of this activity. Now we're going to get into a little bit more challenging arena here. So we're going to configure a numbered ACL on router 1. We're going to permit any outside host to access DNS, SMTP, FTP on PCA, on the server PCA. So this would be the destination, right, of where people are trying to get to. We're going to deny any outside host access to the HTTPS services. Well, let's check and see, is HTTPS actually activated here on this server? And in fact, I think I see why they're calling it a PC. It doesn't appear that, whoops, I didn't want that tab. Yeah, typically you'll see a different interface for a pure server here. So we'll assume that HTTPS is running, and we can actually do more than assume. Let's go ahead and say https://192.168.1.3. Okay, so it is running HTTPS, and you can see this is activity's probably due for an upgrade here, right? We're on Packet Tracer 8.0, and it's referencing Packet Tracer 6 and 7. Again, still a great activity, but got some old information in there. All right, so we're on router 1, And then we're going to permit PCC to access R1 via SSH. Now, let me ask you, we already did this on the VTY lines. And so this is one of the confusing parts for learners is they say, well, wait a minute, we just did access list 10, allowing only PCC to access routers 1, 2, and 3. So why now are we having to do this? Well, remember, the first ACL was applied to the VTY lines, and it's a standard ACL. We can only filter based on source. This is an ACL that's going to be placed on an interface, right? So this is going to be placed on an interface. Specifically, if I roll up here a little bit, it's going to be placed on serial 000, this interface here. And if I'm not allowing SSH through inbound that interface, it'll never make it to the VTY lines. And so this is why we have to allow the SSH protocol as part of this ACL, or else it would be moot. The ACL on the VTY lines. The traffic would never get to those VTY lines, right? I should say that, the SSH traffic, someone trying to log in, would not get there. So let's scroll back a little bit so we can see our definition. So let's dive in and let's knock this extended ACL out, right? Because the number is 120. So if I was to say access list and do a question mark, you can see 1 to 99 standard, 100 to 199 is extended, right? So we're going to say access list 120. And what are we going to do? Well, let's do it in the order they present it. This is going to be important as well, because I believe in a lot of the ACL activities, Packet Tracer is looking for things to be entered in exactly as they listed out. Now, it doesn't say that, but it's always a good rule of thumb. So permit any outside host to access DNS, SMTP, and FTP services on PCA. And so what we're going to say is, access list 120. Now, DNS can use TCP, but it is a UDP-based protocol first, right? Before it gets to where it might use TCP. So we're going to say access list 120, UDP, any. So I'm allowing UDP from anywhere to go to the host 192.168.1.3. Now, if I hit enter right here, I'd be allowing all UDP traffic that comes inbound on that serial interface to make its way through to PCA. Now remember, we're not asking for any, or we're not asking for all UDP traffic. We're asking for what kind of traffic? Equal to, what did I miss out here? Access list 120, of course, I leave out my permit statement. Permit UDP any host 192.168.3, and it's going to be equal to what kind of traffic, right? We said DNS. So you could put 53, but it's going to get translated out to domain anyway. So let's put equal to domain. The next ACL statement, the next access control entry is going to be access list 120, permit, and here is where we change the protocol, right? Because SMTP port 25 and FTP, and remember we've got FTP is port 20 is data, 21 is control. However, we're going to just go ahead and say FTP here when we get to the FTP rule. But we're saying permit TCP traffic from anywhere to get to the host 192.168.1.3 if it's equal to what? And we said SMTP. Right? So we'll say SMTP, or you could, like I said, say 25. Now this last rule, all we need to do is pull back SMTP and say FTP, because it's using TCP, we're allowing it from anywhere, and all we have to do is change what would be the port number. In fact, if I do a question mark, and you can actually still see above there that, where's it at? Right up here. Where did it go? Yeah, it's showing you the list of what you can put in here. So there is no FTP per se. So we would end up putting, we could end up putting 21. Watch, if I put FTP, let's see if it takes it. It does take it, even though it didn't show it there from the drop down. Or you could have said, use the port number, I should say, 21. All right, or 20. Okay, so now we're on to where we're going to start denying things. So deny any outside host access to HTTPS services. Well, again, hit the up arrow. We can change this to HTTPS, and we're not permitting, we're going to deny what's happening here, right? So we're going to deny the traffic. Okay, so we're going to deny HTTPS. Let me look at this rule, make sure we're good here. Access list 120, deny TCP any host. And again, we're saying the coming, any traffic coming from anywhere going to the host 192.168.1.3. Again, I'm just double checking the rules to make sure that they're right here. And you'll notice we're not getting any points right now, and we probably won't until we go to apply this. All right, so that looks good. Or actually, I said HTTPS, probably have to put 443. Okay, and then we've got our, I'm looking back up here, permit PCC. So here we go again. So we're going to say access list 120, permit TCP, permit TCP from where? From anywhere? No. Permit TCP from host 192.168.3.3 going to host 10, and actually, it's not 10. It should be, I'm pretty sure PCA is 192.168. Yeah, 192.168.1.3. So we're going to permit TCP coming from PCC to, to access router 1, not PCA. Okay, so it's going to be 10.1.1.1 is the IP address. So that is right, 10.1.1.1. So there we go. Now, we're not done yet, because if I hit enter right now, I'm allowing TCP connectivity of any protocol that uses TCP to hit router 1 to be permitted. But we want it only if the destination IP is 10.1.1.1 and the destination port number is what? 22 for SSH, right? All right, so that is the whole ACL. Do show run. Do show run. We'll say do show access list. So do show access list. Well, there's my access list. I don't need the deny any at the end. Now we just need to apply it to serial 000, where I'm going to say IP access group 120 in the inbound direction. And here we should pick up a few points. And we do. We get 4 points for that. So that is the ACL 120. Whoops. And let's go ahead and save our config just in case. And let's go ahead and see. Be sure to disable HTTP and enable HTTPS on server PCA. Disable HTTP and enable HTTPS. Whoops. Desktop. I'm going to close that out. And there's typically a services tab, and I'm probably just not looking in the right spot here. Yeah, there's typically a services tab when you have a server, but here we don't. So we're going to leave that the way that it is. So we configured the ACL, we applied it with the access group command. Now let's verify that PCC cannot access the server via HTTPS. And you can see when I'm clicking on these pages, they're not changing. And if I hit go, nothing's happening. In fact, let's go ahead and take it all the way back to the beginning here. And you can see the green lights, right? They're flickering all the way up to that interface, serial 000 on router 1. Definitely not getting through. However, chances are you're not going to have green lights to look at. So here's what we're going to do. We're going to say show access list on router 1. And we can see that that deny rule is matching, right? All kinds of traffic I just generated there. So we're very happy with that. All right, so now we're going to modify the existing ACL on router 1. Now, part 4, this is the part that causes a ton of confusion for learners, right? And it's all about that requirement statement right there. But I'm going to walk you through it, and it's going to make a lot of sense. So we're going to modify this existing ACL. So ACL 120 is going to be modified. We're going to permit ICMP echo replies. We're also going to permit unreachable messages from the outside network, meaning from anywhere out here, right? So it's going to look a lot like these permit UDP any, permit TCP any, right? Except now we're talking about ICMP, echo replies and destination unreachable messages from the outside network relative to router 1. And then we're going to deny all other incoming, right? So deny ICMP coming from anywhere, going to anywhere, right? So let's go ahead, and I'm sorry, it's not part 4, it's going to be part 6 that creates even more confusion. All right, so let's get into global config. Now, to modify the ACL, we have to use that IP keyword. So IP access list, and here the order of operations changes a little in the command. We have to say extended, and now we put in our ACL number. So we're going to be modifying ACL 120. So I say IP access list extended 120, and now this puts me into the named and numbered ACL configuration mode for extended ACLs. And here's where we would say permit ICMP, and you can see it's just changing the protocol is really what we're doing, coming from anywhere. Now, here's the question, right? It doesn't mention where those echo replies and destination unreachables are going to be allowed to reach. So it's more than just router 1. If I remember correctly, I think what we're saying here is not just allowed, because we're not pinging from router 1 per se, right? We're going to be pinging from PCA. So it's going to be, we're going to allow it to come back into anywhere. So permit ICMP any, and now remember, we don't want to leave it right there. If I hit enter right now, we're allowing all ICMP traffic. And take a look. There are a lot of different kinds of ICMP packets that we could encounter. And so the one we're interested in first is that echo reply. So we're going to permit ICMP from anywhere, and it's going to be allowed to go anywhere behind router 1 as long as it's an echo reply. And so we'll hit enter right there. And then we're going to say permit ICMP any going anywhere. So from anywhere to anywhere, and you can see unreachables, right? And we're going to do all unreachables because it doesn't specify if they're talking about protocol unreachable or port unreachable or host unreachable. So we're just going to grab all unreachable messages, and then the final line is going to be deny ICMP any, because once we've allowed what we want to come through, now we're going to go ahead and block all ICMP traffic, right? And deny all other ICMP traffic. And then give me a second here. Let me see. Verify that PCA cannot successfully ping the loopback. I'm just double checking the requirements here. All right. So deny ICMP any. Now, what's kind of odd about this is that we allow these permit statements here, but again, we're blocking all other types of ICMP packets like TTL exceeded, right? Okay, so we've got our changes to the ACL. Again, I'm just reading to make sure that I've captured everything here in part 4 that we would be doing. And let's go ahead and get on to PCA. And you know what? What I did not do was I did not test to see, could we ping, and what is it asking us to ping here? Verify PCA cannot ping the loopback of R2, which is 192.168.2.1. And now it can, right? Because again, I didn't test that initially with that ACL. What we could do, real briefly, is I could go ahead and say end, and we can go into global config interface serial 000, say no IP access, no IP access group 120 in, and well, we were, you know what, that's right, we were blocking it before, so that's not going to have the desired effect. So instead of manipulating the ACL to allow me to break ping for PCA, I'm just going to leave the ACL on there, and you can see, excuse me, that we can ping, right? So that's working great. So verify that PCA cannot ping it, but unfortunately I had already made the fix, and we went ahead, we fixed the ACL, so now I can ping the loopback interface. So now what we're going to do is we're going to create a numbered IP ACL here on router 3, and unfortunately Cisco ConPA55, we have to put Cisco ENPA55. We got to drop these passwords back on here. All right, so now we're on part number 5. So we're going to deny all outbound, let's read that, all outbound packets with a source address outside the range of internal IP addresses on router 3. So this is actually not, this is probably pretty easy compared to what we're getting ready to do in part 6 and what we just did in part 4. So here, we're basically saying that on this gig interface here on router 3, and I believe it's gig 001 probably, that we're going to check all of the incoming traffic. And if the traffic is not from the 190, if it doesn't have a source address of 192.168.3.0/24, so if it's not in that /24 range for that 192.168.3, we're going to deny that traffic. So let's go ahead and handle this one. We'll get into global config, and we're going to say access list. And this is going to be an extended ACL by definition. And we're simply going to say permit IP 192.168.3.0. And now we have to do a wildcard mask. Remember, it's the inverse of a dotted decimal subnet mask for that subnet. And that's all our statement says, right? We're going to permit all traffic. And that is what the keyword IP stands for. And this is very, very important. If you say permit IP, you are saying permit ICMP, permit TCP, permit UDP, permit everything. Everything, all traffic. That's what the IP stands for, right? So we're saying we're going to permit, if it's coming from this subnet range, all IP traffic going where? Going anywhere, right? So we're going to allow it to go anywhere. In other words, the destination field in the IPv4 header can be anything. And that's exactly what we're looking for, right? Okay, so let's take a look here and make sure. And yeah, that's right. They tell you the gig 01 interface. So that's the ACL right there. Let's get into Gigabit Ethernet 01 IP access group. And you'll notice when we apply ACLs to the VTY lines, it's much different than when we're applying ACLs to physical interfaces, right? So access group 110, and it's going to be in the inbound direction. You can see we've bumped up to 87% there. So that was part 5. And so now we can test that, right? So let's see if traffic is allowed to go. And I can't get there. Let's see if HTTP, I think, should still be working since I didn't turn it off, possibly. Or better yet, let me see if we can. Yeah, we're not going to be able to ping over there. I guess let's go ahead and see if we can still SSH, I guess would be our test, to SSH up to router 2. And there we go. Cisco SSH PA55, and we're in, right? So that ACL is functioning as expected. It's allowing traffic from the 192.168.3.3 PCC to go through that interface to go SSH over here to router 2. All right. Now we get down to the trickiest of this activity right here. And believe me, this the first time I did this, I definitely had to check on the multicast range, but then it made a lot of sense. And I still remember dealing with that multicast range. So this is going to be placed on router 3. And we're going to create a numbered IP ACL. It's going to be numbered 100 on router 3. Now, we're going to block all packets containing the source IP from the following pool of addresses, right? Any RFC 1918 private addresses. And this is where it typically trips up learners. So let's take a look at RFC 1918. I've got this all staged and ready to go here. So here is the range of addresses they're talking about. Now, remember, when we're talking about the RFC 1918 address space, and this is a critical point, these are ranges of addresses. It is not the entire class A. Well, in this case, it is for the 10 dot, but it's not the entire class B range for 172.16.0.0, right? It doesn't just go from 172.16.0.0 to 172.16.255.255. And it doesn't just go from 192.168.0.0 to 192.168.0.255. In other words, take a look over here at the prefix lengths that we're going to be working with. Now, the 10 dot, that's a different case, right? Because it is saying it goes from 10.0.0.0 to 10.255.255.255. So this is the easy one. These are the difficult ones to comprehend, to understand what's going on, because typically you see, 172.16, well, that means that the subnet mask is 255.255.0.0. Therefore, my wildcard mask should be 0.0.255.255. That would be wrong, because we're talking about a much larger range of addresses that are these RFC 1918 addresses. And the same thing is true here with the 192.168s. It's not a /24, it's a /16. And I'm going to explain the subtlety behind this when we get over to the screen where we have some more space. But again, remember, these are the ranges. So don't confuse the RFC 1918 private address spaces for the 10, the 172, and the 192 with the default classful subnet masks. For the 10 dot, yes, it's going to work, but for the 172 and the 192, you would run into issues. So we're going to break that down right over here. So let's start out with those denial statements. And let me read the rest of this, because I think, yeah. And of course, they put down here at the end, by the way, permit SSH traffic from the 10 network to return to the host PCC. So again, they conveniently dump this at the end of the requirement statement, because if you started, the very first statement you put in here would be deny IP, 10.0.0.0 and then 0.255.255.255 any. Well, then it's going to match, this SSH traffic we're talking about would match that ACL, that access control entry, that ACE, before it got to your permit if you did things in order, which is why read this entire statement a couple times and recognize at the very end here, they drop that little zinger in there, right? Because if you don't put that entry in first, and you'll see what I mean here when we get the entries in here. So let's go ahead, let's jump out of the interface mode, and let's say access list 100, permit TCP, and we've done a rule like this before, right, for this SSH traffic. However, this one's even going to be a little bit more different. 0.255.255.255. So what we're saying here is permit TCP from any 10 dot address, right? From any 10 dot address to return to the host PCC. Now, if you look down here, you can see the ACL, we're going to be applying this to the serial interface, right? The serial interface sits right here on, I went yellow, we're going to do red. Sits right here on router 3, meaning allowing traffic to return. It's going to be coming back in the inbound direction is how we're going to be assessing and evaluating this traffic. So permit TCP from any 10 dot network, right? So 10.1.1.1, 10.2.2.2, to come back in to this network. Now, what you might do, and this is the most common mistake I'll see learners make, is they'll say, okay, well, permit it to come back in and go to host 192.168.3.3. But let me ask you this. It's asking you to permit SSH traffic from the 10 network to return to the host PCC. Have we identified in this ACL that, yes, it's TCP, but have we said only SSH traffic? We haven't. And this is the most common mistake, is learners will say, equal to 22. They'll put it at the end. But what that implies is that the port The destination port is 22 on the PC. But remember, the PC is who is initiating these SSH connections. And it's not using port 22 as the source port. PCC, when it's trying to SSH to router 2 or to router 1 or wherever, right? The destination port is 22. Those are your servers or your SSH servers. PCC is an SSH client. So it's going to have a random high port number that it's going to use. So in other words, we need to say that we're allowing TCP traffic back from this source with a source port of 22. The destination port is going to be some random high port number, right? But it's the source port in the return traffic that's going to be 22 because it's coming back from the SSH server. Again, PCC is not an SSH server. It's an SSH client. And that little trick right there, I should call it a trick, but that little subtlety right there trips up learners a lot. Because again, typically what I'll see, I'll get contacted and they'll say, hey, my ACL is not working or I didn't get the points, and I'll pull up ACL 100 to look on router 3 and they can't figure it out. And it's because they've got the equal 22 at the end. But that implies that it's the PC that's the SSH server, and it's not, it's the client. So that's the first line right there. And again, and it gets trickier as we move along here. So that's line number 1 right there. Let me clear the screen for us here. Okay, so we do what they ask at the end first because we've got to permit that traffic first. So now we get into these RFC 1918 private addresses. Well, this is where you get lulled into a false sense of security by saying, whoops, sorry, we're going to deny. Deny IP, remember, it's saying all traffic. So deny IP from 10.0.0.0, 0.255. And remember, that's the inverse of the wildcard mask. Any. Because we're denying all traffic from any 10 dot address in this second access control entry going anywhere, not just to the host PCC, but anywhere on that network behind me. And so now if you look at these two statements, you should see why we had to put that first, the permit statement for SSH. Because if that statement is not first in this ACL, and this statement is first, the SSH traffic's blocked. It'll never make it back through, right? Because remember, ACEs, the access control entries, are evaluated in order, in the order in which they appear in the ACL. So be aware of that. Now we get down to the one where this, and again, this is typically what I see, access list 100, deny IP, and they say, okay, well, I did the 10 network. Now I'm going to do the 172.16.0.0, and I'm going to say 0.0.255.255, any, because the 10 dot address worked out perfectly, right? It functions great. However, this does not account for the 172.17, the 172.18, all the way up to the 172.31.255.255. Remember, don't confuse the RFC 1918 address space with what would be the classful default subnet mask, because that statement right there is only blocking the 172.16, 00 to 255.255. Doesn't account for all those other addresses that are in that RFC 1918 block. So now here's where the question comes up. Learners will say, well, I don't get it. Why does it say it's a /12? That doesn't make any sense to me. And again, if we drop back here real briefly, you can see right here, it says 172.16/12. So let me actually get rid of that underline and we'll come back over here. So here's what they're saying, right? So if it's a /12, that means the first 12 bits are set, right? Meaning that the first 12 bits aren't changing in terms of what those values could be. So what does that look like for a 172? Well, we'll break it into binary. Again, we're looking at the bits. So 128 is on, 64 is off, and then 32 would be 160, and then that would be 176. So that's going to be off. And then 8 is going to be, let me make sure, 128, 160, 168 is going to be on. Now we only need 4 more, and then on, and then off, and then off. So 128 right there, plus 32 is 160, 168, 172, right? So 128 plus 32 plus 8 plus 4 is going to give me 172. All right, now, it's the first 12 bits. So if 16 is the starting range, 128 is off, 64 is off, 32 is off, but 16 is on, right? So here is the /12. This is what the /12 is referring to. The first 12 bits, and that's, again, if we go back to the RFC, they show you right here, 172.16. These 12 bits that make up 172 and 16, which I've got written out right here, these do not change in the range that we're dealing with, right? Okay, those are set. What can fluctuate are the remaining bits that are here. So we've got these 4 bits right here in the second octet. I'll put a period. And then you're going to have, 1, 2, 3, 4, 5, 6, 7, 8. And then that last octet, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we've got the 172, 16 / 12, right? Now, remember, the range goes from 172.16 to 172, and where am I going to write this? We'll write it right underneath here, all the way up to 31.255. Again, remember, it's these these little, dashes I've got in here. These are values that can change. Excuse me. But these first 12 bits cannot. And here's what I mean by that. So what if this bit is on, the 8-bit? So now it becomes 172.24. Is that still in the range? Is that still in that RFC 1918 range? Well, yeah, because it goes from 172.16 to 172.31. What about if I turn that bit on? Now it's 16 plus 8 plus 4. So 16 plus 8 is 24, and 4 is 28. So is 172.28 in that private RFC range? Yes. We'll put the 2 here. Now I get 172.30. Is that within the range? Yes. And finally, 172.31. And there it is. So that's why they say it's a /12, because these bits are locked in. It's the remaining 20 bits that can be manipulated, that can change. And if I was to put all ones in here, it would be 172.31.255.255. And that's how they come up with that range, right? So we start out with the /12, 172.16, and those bits are locked in. And then we've got 20 bits out here that we can then start, if we needed to use, we can go ahead and use those, but it gives us that range for that RFC 1918 range. So if it's a /12, that means that we've got 255, 255, again, for the subnet mask, for a /12. Meaning the first 12 bits represent the network portion of the address. It'd be 255. And in the second octet, it's only the first 4. So 128 plus 64 is 192, 224, 240. Meaning, I'm going to take the inverse and let's finish this out. And again, it would be 240.0.0. So that's a /12 subnet mask right there. What is the inverse of that? Well, it would be 0.15.255.2 255.255.255. And again, you can see why this little /12 and the 172 can be confusing because, again, learners are so tied into and locked into, oh, 172.16, whatever, it's a class B, 255.255.00. No, not when we're talking about the RFC space, right? Which is a larger range of values. So let me clear the screen here. And before we get logged out, so we don't have to type the passwords in. So it's going to be deny IP 172.16.0.0, right? Because the first 12 bits, this is where we're starting from, but the wildcard mask is 0.15.255.255 because the /12, and don't let me forget my any, the /12 is represented, that /12 range is represented by that value right there. So now we get down to the next one, which you're probably guessing is going to have the same little twist, 192.168.0.0. And here we go, right? So it's a /16. You can see right here. And what that means is it's not a /24. The RFC reserve range for this Class C address, 192.168, this range is larger than the single 192.168.0.0 with a default subnet mask of 255.255.255.0. The range goes all the way up to 255.255 over here on the right-hand side, right? So it's a /16. Well, we play the same little game that we just played. We're saying the first 16 bits, and this one will be a little bit easier, 128, 192, and then 1, 2, 3, 4, 5, 6, and then 168, 128, 0, 160, 0, 168, and then 0, 0, 0. Let me make sure I got that right. 1, 2, 3, 4, 5, 6, 7, 8. Right. And so then we have these 8 bits here. So 1, 2, 3, 4, 5, 6, 7, 8. And we've got these, and I'll just put the 8 down here for the last 8 bits that are going to be down here. So I've drawn all the dashes out. So /16 means that we're starting with these 16 bits locked in, right? So we start with this 172.16, right? That's where the range begins. And it's not until I get out here that I can manipulate and have those values change. So if it's a /16, right, we know that it should be a 255.255.0.0. But again, if I was to put a 1 here, right, then we get 192.168.128. And it's a /17. And then 192, and then 224, 240, 248, 252, 254, 255. Right? And that's where the values would end up changing after 192.168. But again, these first 16 bits start the range. We're locked in right here. And by virtue of the fact that we make it a /16, we're saying that we can have all these other values out here. And then again, if we used up all these bits, it would be 255 as well. So this one's a little easier than that 172, no doubt. And let's go ahead and say 0.0.255, oops, any. And that is what that statement looks like. And again, based off our conversation around the 192 and the 172, that is why they look like that. Now, okay, so this is a kind of an easy one here, right? This is like the 10 dot. So we're going to come back and say access list 100. And we're going to deny, 127, that loopback address, 000, and it's going to be 0.255.255.255 any. So that's kind of one of the easier ones to deal with. Now, deny IP. Forgot my IP in there. So the most onerous one that we're going to deal with is this next one, this multicast, an any IP multicast address. Okay. Well, what does that look like? Well, remember the multicast, and this is that class D, so to speak, right? That comes after the 192 range. a multicast address range starts with 224.0.0.0. Now, how would we look at this based off the conversation about the 172.16 and the 192.168? How many bits are locked in here to start this range? Well, 128, 192, 192, 224, and then 0. That starts this range, right? 1110 would start the range. And so what you'll see is this represented as a /4. So 224.0.0.0 is represented as a /4 because those first 4 bits are what would be locked in. And here's what I mean by that. Remember, the end of this range is at the 239, and I'll just say, 255.255.255. And so if we started using other address bits, right, those values could change, but we'll leave it as a /4 because the first 4 bits, right, represent that class D address space. And so if it's a /4, what does that mean in terms of the subnet mask? Well, it would be 240, right? Because we'd have 1, 2, 3, 4. So 128, 192, 224, 240. We'd be locked in there at the 240 dot, what am I doing here? .0.0.0. Sorry about that. .0.0.0. That would be, or I'm sorry, 250. This one drives me nuts. Yeah. So 240.0.0.0 because the inverse of this is going to be 15.255.255. So the wildcard mask is going to be 15.255, 255, 255. And that's the value that we should end up with for this multicast range. And it's because we're dealing with that /4 value. So let me go ahead and erase this. And let's get this dropped in here. So we're going to say access list 100, and we are denying IP from 224.0.0.0, and then our subnet mask again was going to be the 15.255.255.255 any. And that should be the deny statement that works for us. And then, hold on one second here. Let me double check this. Because we're denying a whole bunch of stuff here. We're permitting one thing, but I think we're going to have to allow all other traffic. I'm just checking to see where it's... Yeah, we've got to allow all other traffic to come through, or it's going to be blocking everything else. Let's go ahead and say access list 100, 100 permit IP any. And let's do that. All right, and it bumped us up to 91%. So, okay, so we've got that taken care of. So now we just need to get into interface serial 001 is what it's saying here. And we're going to say IP access group, what was that? 100 in the inbound direction. And the hope is that this is going to bump us, and it doesn't. It took me to 95, so we'll see what's going on if there's something else we need to manipulate here. Okay, so block all from the inside network. So hold on a second here. So it says you should also block traffic sourced from your own internal space if it's not RFC 1918 address space. Okay, that's got to be what it was looking for. And let me do a quick check results here to see if we missed something. Okay, so ACL 120 on, so something on router 1 was not correct. So we're going to have to, so that, the toughest ACL was good, which is this one here. So let's confirm some things. So from PCC, let's ping 192.168.1.3. And the echo replies are blocked by the ACL because they're sourced from that 192.168.00/16 address space. And that's what we're seeing there. So now let's go ahead and try the SSH-L for SSH admin. Can we get to 192.168.2.1? And it should fail. All right, so it looks like this ACL is working good so far, but because again, when the return traffic's coming back, it's coming back from an RFC 1918 address, this 192.168. That's why it's not working. But now let's rerun that same SSH command, and let's go to the 209.165. This is not in that RFC address space range, 200.225. And there we go. So Cisco SSH PA55, and we're into router 2. But now what we want to do is we want to go back and take a look at router 1. And we want to take a look at ACL 120, Cisco Con PA55, and Cisco ENPA55. All right, so show access list 120. And this should have been the easier of the activities. And so now we're going to have to roll back up here to 120. And let's just quickly see if we can sort out. I went past 120 there. Okay, so permit any outside host to access DNS. We've got that. SMTP, we've got that. And FTP on PCA, we've got that. So permit UDP any host 192.168.1.3 domain, SMTP and FTP, which are TCP. And then we've got deny any outside host access to HTTPS on PCA. And we did that. Deny TCP any from anywhere going to the host 192.168.1.3 if it's equal to 443. And we've got matches on that. So that looks good. So it's got to be permit PCC to access R1 via SSH. Permit PCC to access R1 via SSH. And let's try that. Let's go SSH to the 10.1.1.1. Let's see if this works. 10.1.1.1. And it does. Cisco, what was it? SSH ENPA55. Cisco SSH ENPA55. I am putting the right password in, I believe. But, oh, you know what? I think we're... No, it should be... Where are we at? Permit TCP from host PCC to the 10.1.1.1. And this... You know what? I'm wondering if... Yeah, that should be working. Let me take a look real quick here. Let's look at the input SSH access class 10 in. So that should work. So, and the password, the username, I'm sure they've got it encrypted. Yeah, so I can't see. Oops, sorry. Is there a username? Yeah, SSH. So I can't see what the password is. Let me try this one more time here. So SSH -L SSH admin to the 10.1.1.1. And it allows me to connect Cisco SSH PA55. Okay, I was not typing the password. I was certain I had it right. Okay, so that ACL is working, and we should actually see that reflected here if I say show access list. Yeah, okay, so there we go. So it is working. So now we're down to the addition that we made, which was permit ICMP any echo reply, and that's good. Permit ICMP any unreachable, and that should be good. And then deny ICMP any. So what is it that it doesn't like about ACL 120? And it's applied on serial 000, and there it is, IP access group 120 in. And that's correct. So it's got to be something inside that ACL. So Verify PCC cannot access, and we know that. Permit ICMP echo replies and destination unreachable messages from the outside network relative to router 1. Deny all other incoming ICMP packets. Yeah, that has got to, and I'm wondering if it's because I took it off and put it back on that I messed it up. So let's say show access list. So this might be a packet tracer snafu here. Show run begin access list. So here's what I'm going to do. I'm going to copy this. Let's copy this set of text right here. All right, so let's get into global config. We'll go into interface serial 0, excuse me, 000. No IP access group. 120, oops, sorry, not one, yeah, 120 in. And so you can see they take points away for that. And I'm going to say no access list 120. Right, so the ACL is gone. So let's go ahead and drop the ACL back on here. And that still takes me to 91. And let's get into interface serial 000 and say IP access group 120 in. And it still leaves me at 95. So there's got to be something up with the statements that I've got in here. So let me pause. Let me troubleshoot for a second. Oops, sorry. Let me troubleshoot for a second. And then I will be right back. So you can call it tunnel vision. You can call it whatever you want. But I took a break, came back, sat down, looked at the ACL, and I was like, I swear I put a permit IP any at the end of this ACL. And that is what was missing. So for whatever reason, I don't know if it was when I pulled it out and then put it back in, I didn't have it in there, but we're at 100%. That was the command right there that was missing. In fact, if I was to say, let's display the access list here. If I was to say do show access list and say no 90, it drops it to 95 points. If I go ahead and say permit IP any, we get 100 points. I swear I had put that in there and was, again, just very meticulously looking over things. And so that is the entire activity. So one of the easier ACLs is what ends up tripping me up here and causing all of my confusion anyway. All right, well, that is going to do it for Packet Tracer Activity 26.2.3, where we were mitigating attacks using IP ACLs. If you guys have any questions, let me know. And that is all I've got in this video. Thanks so much for watching. Hope to see you in the next video.